This is a quick help video for my students related to ALEKs 7.4a. I'm going to do a quick example on each one of them. Quick, that's funny, actually. They're not quick. The first one I'll do is over rational function, linear over linear. There are two topics. Look at the instructions. It says, start by drawing the asymptotes, then plot 2 points on each piece. That's on each side of the asymptotes. Finally, click on the graph a function button. So don't click on the graph a function button till the end. I found that to be an issue. All right, vertical asymptotes are where the domain is not, where X is no longer in the domain. What makes what's not in the domain? Well, the value of X that makes the denominator 0. So X cannot be equal to -2. So, and when X is -2, my numerator is approaching a finite number. So I know I have a vertical asymptote. Where is my horizontal asymptote? Well, I had in behavior. If I look at my dominant terms, 3x over x, my x cancels. And as x goes to infinity, y goes to a +3. There's my asymptotes. I personally like to use this plot a point anywhere. And so I'm going to pick 2 points on each side of that vertical asymptote per the instructions. So I'm going to pick a point at x equals -3. Then all I'm going to do is look at the numerator and the denominator. I don't need to actually calculate the fraction. So if x is -3, 3 times -3 is -9, plus -3 is -6. That's in the numerator. And the denominator, -3 plus 2 is a -1. There's 1 point. I plot it. Then let's plot another point. Let's pick -4. -4, and when x is -4, what's my numerator? I got -12 plus 3, that becomes -9. And in my denominator, -4 plus 2 becomes -2. I've got another point. Now I'm going to plot points to the right of my asymptote. So let's pick x equals -1. When x is -1, what's my numerator? I have -3 plus 3. It's going to end up being 0 because nope, that's not what we want. Well, okay, I didn't need it. I don't need it. I'm not sure how to get rid of that. Okay, well, what's the denominator? -1 plus 2 is 1. Plot. All right, now let's pick x equals 0. When x is 0, I get 3 in the denominator and 2 in the numerator. Plot that point. I'm done. I got 2 points on each side. I can hit graph a function. Boom, it looks good. I'm happy with that. If you hit this graph the function before you plotted all your points, you get something weird. And I don't want you to freak out over that. You can continue and add your points and then hit graph the function later, but it's best if you do it at the very end. Check, and we should be good to go. Okay, now let's do the harder one, which is graphing a rational function with more than one vertical asymptote. I'm going to have to show you what to do. Okay, we got to do some factoring. Okay, so I'm going to write this function down and I'm going to do some factoring. And I'm going to show you what I have if you want to see what's going on. So I have f of x equals, I have x squared plus 8x plus 16 over x cubed plus 6x squared. I'm going to pause, I'm going to factor, and then I'm going to share my screen with you. All right, so I've done some factoring. Let's share my screen. Come on, there we go. Okay, so I took the original function, I factored it. I factored the numerator and the denominator. We need to determine what's in the domain, and that is all values except x cannot equal 0 and -6. And the reason why is because at those locations, the denominator is 0. When x is equal to 0 or -6, I have a number in the numerator, so I know that those are actual vertical asymptotes. So I have vertical asymptotes at 0 and -6. Horizontal asymptote has to do with in behavior. All I need to look at is my dominant terms. If I look at x squared over x cubed, that ends up being 1 over x, and as 1 over x 1 over x goes to 0 as x goes to infinity because my denominator becomes bigger and bigger and bigger. So I have a horizontal asymptote at 0, y equals 0. Lastly, if I need to know my intercepts for this one, and I know that that occurs when my numerator is equal to 0, and that would be when x equals to -4. So now I have to have all that information. So you need a piece of paper and pencil when you do this. And then I'm going to go back to my ALEKs. Got to plot all that. First thing I'm going to do is my asymptotes. I got one at 0. I got one at x equals -6. I have a horizontal asymptote at y equals 0. And notice they say to plot any intercepts. So I've got to actually plot those intercepts. And I have one at -4. So there's my intercept. Okay, so you can see my little point there. Okay, now I got to plot some points. It says at least 1 point on each side of the vertical asymptote. I'm not sure that's going to cut it, but let's see. Let's pick a point that's to the left of that vertical asymptote at -6. So we'll pick -7. And then you can't see my factored form, but I will figure out based on that -7 plus 4 is -3. I have -3 times -3 in the numerator, that's +9. And in the denominator, -7 times itself gives me +49. And then -7 plus 6 is -1, so that becomes -49. -49. So there's a point. It's there. I've plotted it. Maybe I'll just plot 1 point. We'll see. Now let's plot 1 point to the right of that vertical asymptote, which will be, we'll pick -5. And then we do the exact same thing. So -5 plus 4 is -1. -1 times -1 is 1. Again, I'm looking at my factored form. I'm plugging in -5 squared. That's +25 times -5 plus 6 is 1. So I get 25 on the denominator. Plot. Okay. Now, let's pick, I don't know, x equals -1. I'll pick another point closer to that second vertical asymptote. Let's pick another point. -1 plus 4 is a +3. 3 times 3 is a +9. And then in the numerator for -1, -1 squared is 1. -1 plus 6 is a 5. Plot it. Okay, let's go to the right of x equals 0. Let's pick x equals 1. Doing the same thing. I got 5 times 5, that's a +25. And in the numerator, I'm plugging in 1. I get 1 times, I got 7. Plot point. Pick another number. I'll pick 2. Let's plot a point. 2 plus 4 is 6. 6 times 6 is 36. In the numerator, 2 squared is 4. 4 times 8 is 32. I did that right, please. Yeah, it looks right. Plot. Now let's check. Now I'm going to hit my graph, see what it does. Looks like it's very possible. Let's go check. Told me I was correct. Okay, so I guess what the key is that I'm trying to tell you is you got to have a piece of paper and you've got to do a lot of work off to the right. And also I feel like using this plot a point and just using, just putting in your denominator and your numerator and just let it plot it is good. Okay, I hope that helps you. I know this might be a challenging ALEKs lesson.